Hello friends, welcome to Power Electronics. Today we will discuss the choppers. Before discussing choppers, we must know that how to convert the AC voltage into DC. We use rectifiers to convert the AC to DC. Also we have used phase converters. In previous classes I have discussed the complete phase controlled rectifiers where we have convert AC into DC. So question arises, why do we need DC? So in industrial applications, what we require as per the usage, we have subway cars, we have trolleys, buses, battery operated vehicles and battery charging. All required DC. So how we get? By the rectifier or phase controlled rectifiers. But problem here is that to control the subway trolley or battery operated vehicles or braking, we required a variable DC. So for a variable DC, we focus our interest on choppers. So if you look at the definition, the conversion of fixed DC voltage to adjustable DC output voltage through the use of the semiconductor devices. There are two methods to change it. First is AC link chopper, where what we would do here, we convert DC by the use of help of inverter to AC. Then we step up or step down with the help of transformer to again to AC. Then we use the rectifiers or diodes to convert into the DC. So this process is very costly, bulky and less efficient because in the process of conversion lot of the energy is lost. So what we use? DC choppers. In a static circuits, it converts fixed DC input voltage to the variable DC output voltage just by switching it, switching the load or disconnecting the load. It is so fast so that we get our required waveform. So example of DCs are trolley cars, marine host, forklifter trucks and marine haulers. So we use them. So if you look at the choppers, they are also used in the speed control and braking. Smooth control, higher efficiency, it has faster response and regeneration. So all of these having a very good qualities and we get a variable DC. Choppers are now being used all over the world for rapid transit system. They are used in the trolley cars, marine hose, forklift trucks and marine haulers. The future electric mobile also have scope in it because for the braking system we will use the choppers. The power semiconductor devices used for the choppers can be force commutated thyristors or we can say the BJTs or power MOSFETs, GTO or IGBT. When switch is off, no current can flow in the circuit. When switch is on, the current flows in the direction. The power semiconductor devices have also the on state voltage drop of 0.5 volt to 2.5 volt as mentioned by the PS Bindra. So we will discuss here the principle of the choppers. So I have written it in point wise. So as you can see in the diagram here, Vs is the source voltage, SW this is the switch. How we can represent the chopper? Most of the in examinations they have given various symbol and you have to select which one is of the chopper. So it is a dotted rectangle. Also we have freewheeling diode and inductor and connected with the load. So Vs is the supply voltage. As you can see here, it is on, then it is off, then again is turn off, then on and then turn off. You can see it's kind of a rectangular waveform. So whenever triggered here, when the chopper is here, when the switch is on here with the source voltage, the current starts flowing from here this path and passes through inductor and then through the load and then comes to the back path. So we can see the inductor is charged with the polarity plus minus. When the switch gets open, then the no current flows in the circuit. So this inductor changes polarity and discharge to the freewheeling diode, as you can see in also in the diagram. Vs, how you can see this is a rectangular waveform. The period of T on, then it is off, then again it's on, then again it's off. You can see the load current rises here, and when the this switch is off, then the freewheeling diode starts working, then it drops. Then when again we at this instant again we open the close the switch, the current start supply current starts flowing, then again it's off. So you can see the load current is continuous. So the principle of chopper is that a chopper is a high speed on off semiconductor switch. Its switching is very fast. Second thing is it connects the source to the load or disconnect at very high speed. Third point here is that Vs is of constant magnitude. So for the period T on, when the chopper here is on T on, the V output voltage equal to Vs, because freewheeling diode is not conducting at that period of time that this chopper gets turned on. When it gets turned on, the supply voltage gets off. I will explain it again. Here when the current flows here and pass through the inductor and then to the back path, this freewheeling diode act as a open circuit. So Vs voltage is equal to output voltage. Also during the turn off, V output is equal to T on upon the time period. Time period here is complete time period, that is T on plus T off. So what we get, T on off by T is the time period here, T on by V. So what we get, output voltage equal to alpha times of source voltage. So what is the meaning of the alpha here is the T on upon time period, that is duty cycle. The load voltage can be controlled by varying the duty cycle alpha. So by changing the alpha, we can change the duty cycle. Also, the load voltage can be controlled by varying the duty cycle alpha. V equal to F into T on into Vs, where we know what is the here T on. T on is the on time of the chopper into source voltage Vs. So this is the principle of the chopper. When the switch is on, supply is flowing in the circuit, then the source voltage equal to output voltage. When it gets off, switch is opened, the this inductor discharges through the freewheeling diode. So here T on, this is a time period T on upon the complete time period T on plus T off. So here T on plus T off is equal to the time period T.